Imagine looking up at a night sky filled with billions of stars, worlds, and wonders, all seemingly endless. Some of us believe the universe teems with life, while others think we may be alone. Yet no one can prove it either way, until, perhaps, now, recently, scientists made a shocking discovery involving the second planet from the Sun, Venus. They claim to have found evidence that might point to life. How is this possible? Why haven't we detected life on Venus before? And can we really trust this astounding claim? Venus, a once habitable world. Venus is often described as a scorching hellscape, with surface temperatures hot enough to melt lead and thick clouds of toxic gases swirling through its atmosphere. Yet researchers suspect that in the distant past, Venus wasn't always so hostile. Billions of years ago, it might have had vast oceans, mild climates, and conditions not so different from Earth's. Slowly, over about 1 billion years, runaway greenhouse gases transformed the planet. Oceans vanished, temperatures soared, and Venus became the harsh environment we know today. If life ever gained a foothold in that ancient paradise, it may have migrated, perhaps into the ground or high up in the atmosphere, to avoid extinction as the planet grew hotter and drier. But where is the evidence of such life now? Until recently, Venus seemed like the last place we'd think to look. A closer look at Earth's fiery sister. You've likely seen Venus countless times without realizing it. It's the brightest planet in Earth's sky, visible as a brilliant star near sunrise or sunset. Because it's similar in size and mass to Earth, Venus is often called our sister planet. But there the similarities end. Its atmosphere is a dense blanket of carbon dioxide and sulfuric acid clouds. The surface pressure is 92 times that of Earth's, equivalent to standing 3,000 feet underwater. Temperatures average around 880 degrees, 470. Any spacecraft that landed there, like the Soviet Venera probes, lasted mere minutes before succumbing to the inferno. About 67 million miles from the Sun, Venus now receives too much solar energy. Yet 3 billion years ago, the Sun was only about 80% as bright as it is now. Under those gentler rays, Venus might have harbored oceans and mild climates, perfect for microbial life to arise and thrive for billions of years, until a catastrophic shift occurred, possibly caused by volcanic activity, releasing enormous amounts of greenhouse gases and transforming Venus into an uninhabitable world. Phosphine, a smelly clue. The excitement around life on Venus centers on a chemical called phosphine. Phosphine is composed of 1 phosphorus atom and 3 hydrogen atoms. On Earth, this toxic, flammable gas can be produced in 2 ways. Artificially by human industry, it was once used as a chemical weapon and is now an agricultural fumigant. Or naturally by certain anaerobic bacteria living in oxygen-starved environments like swamps and landfills. On other planets, the presence of phosphine would be unusual. If found, it could indicate life or some unknown form of chemistry. Scientists use 2 powerful telescopes, the James Clerk Maxwell Telescope and the Atacama Large Millimeter Submillimeter Array, ALMA, to search Venus's atmosphere for trace gases. To their surprise, they detected phosphine, but phosphine should be destroyed rapidly by Venus's harsh environment. Its stable presence suggests something is continuously producing it. This could mean one of 2 things. Either bizarre alien microbes exist in the temperate layers of the Venusian clouds, assembling phosphine molecules, or some unknown chemical process, unrelated to life, is at work. Caution is warranted. The data must be confirmed and alternate explanations explored. Still, this discovery sends a thrilling signal. Life might be hiding in the most unexpected places. Life against all odds. What would life on Venus look like if it exists at all? It wouldn't be large creatures roaming the surface. The surface is far too hot. Instead, we imagine microbes floating in the cooler cloud decks, sustained by sunlight, trace water droplets, and organic molecules. This idea isn't far-fetched. On Earth, we find extremophiles thriving in boiling hot springs, deep ocean vents without sunlight, even high in our atmosphere. If life can survive these extremes on Earth, who's to say it can't endure the sulfuric acid clouds of Venus? This line of reasoning encourages scientists and space agencies to consider future missions, perhaps balloon-borne probes drifting through Venus's clouds, sampling the air for microbes. Hunting for life beyond. Venus. Venus isn't the only place capturing our imagination. Lately, other worlds have presented tantalizing hints of habitability. Jupiter's largest moons, discovered by Galileo 400 years ago, are prime candidates. Europa and Ganymede, for instance, harbor underground oceans that might host life. NASA's Juno spacecraft recently detected an FM radio signal from Ganymede, similar to the signal type we use on Earth for Wi-Fi. While it's not from aliens, it's more likely caused by electrons interacting with Jupiter's magnetic field. This finding reminds us how dynamic and mysterious these icy moons are. Ganymede is the largest moon in the solar system, even bigger than Mercury, and may have salty oceans beneath its surface. If oxygen and other ingredients for life are locked in the ice or atmosphere, could Ganymede host strange aquatic ecosystems? Just as we dream of airborne microbes on Venus, we speculate about hardy life in Ganymede's buried seas. If tidal forces, radiation, and other energy sources persist, life might find a way. Europa, another Jovian moon, is considered by some scientists to be the most habitable place in the solar system beyond Earth. Its surface is a smooth shell of ice over a vast, salty ocean, potentially twice the volume of Earth's seas. Despite frigid temperatures, 260 degrees, 160 degrees, life might not need sunlight. On Earth, thriving ecosystems exist around hydrothermal vents, deep below the ocean's surface. Europa might have similar vents on its seafloor, warming and nourishing microbes. NASA's upcoming Europa Clipper mission will launch by 2025 to study Europa's icy shell and underlying ocean, searching for clues of life. Meanwhile, the Jupiter Icy Moons Explorer, JUICE, by the European Space Agency, aims to arrive in 2029, armed with powerful instruments to study Ganymede, Europa, and Callisto in unprecedented detail. Beyond Jupiter's orbit, the promise of Enceladus. Saturn's moon Enceladus has also leapt into the spotlight. In 2019, NASA revealed that Enceladus's ocean contains key building blocks for life. Cassini's observations of geysers erupting through the icy crust indicate a hidden warm ocean below. These jets contain water vapor, salts, methane, and complex organics, everything life as we know it needs. If hydrothermal vents warm Enceladus's ocean floor, who's to say strange microbes aren't evolving down there in the darkness? Proposed missions, like the ambitious Orbilander, hope to orbit and even land on Enceladus. Though costly and challenging, such a mission would allow direct sampling of plume material and surface deposits, pushing our search for life to a new frontier. Terraforming other worlds. Lofty dreams and real challenges. While we search for life, we also daydream about making other worlds habitable, a process called terraforming. The idea is to reshape planets like Mars or Venus to resemble Earth's stable climate, abundant water, and protective atmosphere. Mars is often considered a prime candidate for colonization. NASA aims to send humans there in the 2030s, and recent experiments, like MOXIE on the Perseverance rover, have demonstrated we can extract oxygen from Martian CO2. This is a small step, but a crucial one if we ever hope to breathe easy on the red planet. Yet terraforming Mars is no small feat. Mars lacks a strong magnetosphere, has a thin atmosphere, and a cold, dry surface. Without a magnetic shield, solar radiation strips away any atmosphere we try to build. Gravity is weaker, harming human health over time. Generating a thick, stable atmosphere and warming the planet might require unimaginable energy and advanced technology we haven't invented yet. Venus, ironically, might be easier to terraform if we ever solve the problem of cooling its enormous greenhouse effect and dealing with its crushing pressure and acid clouds. Saturn's moon Titan tempts us with its thick atmosphere, abundant organics, and liquid hydrocarbons. Some believe Titan could be terraformed by warming it with orbital mirrors, melting its icy subsurface, and releasing life-sustaining water. But again, these are distant dreams. A new era of discovery. We stand at the dawn of a new era in space exploration. As we launch missions to probe Venus's atmosphere, Europa's hidden ocean, Ganymede's oxygen reserves, and Enceladus's geysers, we inch closer to answering one of humanity's most profound questions. Are we alone? If one of these worlds harbors life, be it microbes in Venusian clouds, under Europa's ice, in Ganymede seas, or near Enceladus's vents, it would revolutionize our understanding of biology and the cosmos. The discovery of phosphine on Venus, even if unconfirmed, is a reminder that the unexpected can lurk in familiar places. The FM signal from Ganymede, while natural, shows how dynamic these moons can be. Experiments like MOXIE on Mars prove we can manipulate alien environments, at least on a small scale, and that the first seeds of terraforming could be planted. Whether or not we find life soon, the search itself pushes us to innovate, to dream bigger. Missions like Europa Clipper, JUICE, Dragonfly to Titan, and Orbilander to Enceladus may soon return data that stuns the world and reshapes our place in the universe. We should consider which worlds to target for human settlements. Will we someday build domes on Mars, float in Venus's upper atmosphere, navigate Titan's methane seas, or burrow into icy ocean moons? Time and technology will tell. For now, we look to the skies, plan our missions, and imagine futures that once existed only in science fiction. Staying informed and engaged. Before we conclude, we'd love to know what other topics captivate your imagination. Do you want to learn more about the mechanics of terraforming, details of upcoming missions, or the chemistry behind alien atmospheres? Share your thoughts in the comments below. To stay updated on the latest discoveries, be they new biosignatures on Venus, fresh data from Europa's plumes, or groundbreaking experiments to produce oxygen on Mars, subscribe to our channel and hit that notification bell. The cosmos is restless, and new revelations emerge constantly. Thank you for joining us on this cosmic journey, and we'll see you next time with more wonders from our planet and the universe beyond.